Now going to question 22. Here we have two histograms and kind of an in-depth description of what the numbers can be. But at the end of all this, we're being asked, what's the smallest possible difference between the two averages? So now getting into the descriptions a little bit, we're seeing that for any of these bars, the numbers are greater than or equal to the number on the left, but less than the number on the right. So in this blue bar here, the numbers are greater than or equal to 20. So they can be 20. They're integers. So they can be 20, 21, 22, 23, all the way up to 29 because we know they can't be 30. Similarly, for this red one, the numbers can be 30, 31, 32, but they can't be 40. So the max that they can be would be 39. So now let's imagine both of these histograms on a number line. Notice that the frequencies are all the same. We have 3 numbers here, 4 here, 7 here, and 9 here. Same thing here, 3, 4, 7, and 9. And so if we want the smallest difference between set A and set B, then that means that we're going to want to maximize the number that's on the left and minimize the number that's on the right. Let's look at their ranges. A starts at 20 and goes to 60. B starts at 10 and goes to 50. So B is the smaller one. A is the bigger one. If we want them to be as close together as possible, we're minimizing their difference, their distance. We're going to want to make B as big as it can be and A as small as it can be. So let's go ahead and try to do that. Let's start with A. Let's make it as small as it can be. So for that, we would make the blue bar 20 because that's the smallest number we could have for that bar. So we'd have 3 20s, and similarly, we'd have 4 30s and 7 40s and 9 50s. And we're dividing all that by 23. So throwing that into a calculator now, we have 60 plus 120 plus 280 plus 450. Divide that by 23, and we'll get 39.56. Now for data set B, we're going to be making all of these as big as possible, but it's a little more careful here because on the big side, the numbers have to be less than whatever the number is at the top side of this. So in this purple bar, for instance, the bigger number could be 19, but it couldn't be 20. So we'll have 3 times 19 plus 4 times 29 plus 7 times 39 plus 9 times 49. Once again, all divided by 23 because there are 23 numbers. Now, if you're picking up on the pattern, these two formulas are identical, except that all the numbers are slid over by 1 on dataset B compared to A. So the difference really is going to be 1, but let's just finish the math. Here, we're going to have 38.56. And so what is that smallest difference? It's a difference of 1 because the difference between 38 and 39 is exactly 1. And the answer here is B.